questions and answer the issue,
No problem.
regardless
I
where
can
they're
read the
coming from.
question and hand over to you. That's fine.
Okay,
Yeah,
very good,
yeah,
very good.
yeah, yeah.
And is this registered, by the way?
Yes, recorded
Okay,
and will be available on the YouTube channel later. Yeah, for
okay,
future.
perfect.
Yeah, yeah.
Hmm.
Iman, we can start whenever you're ready. We are live on YouTube.
Okay, thank you, Basil. Good evening, everyone. I'm Iman Abisab. I'm the chair of the iStruct UAE Regional Group. And I wish to thank you all for joining us tonight here for our 8th CPD event this year, which is organized by our regional group. Our talk tonight will explore voided slab technology, showcasing how it enhances performance and sustainability. And this talk will cover various lab types, including hybrid systems with case study applications and associated carbon footprint reduction. The talk will be shared by 3 presenters from CME Solutions. CME is the first company that has led the voided slab technology, as well as the filling and leveling framework system in the Middle East. And we have tonight Engineer Azam Khalid. Engineer Azam is an engineering
Hello.
leader with, hi Azam. With over 20 years of experience in Canada and the region, he holds advanced degrees in engineering and business, and he has founded multiple pioneering firms, including the Kobiax Middle East and the CME Structural Solutions. Our second speaker tonight is Engineer Ahmad Shayeb, who is a civil engineer and a technical manager with 40 years of experience leading major structural projects across the Middle East. He is a specialist in post-tensioned and voided slab system. And finally, our third speaker is Rasha. Rasha is a structural engineer with experience in design management, value engineering, and hybrid slab system. Rasha plays a key role in developing EVOS and EFIL technology. I hope I pronounced them correctly, Rasha, which we hope to hear more about later in her presentation. Looking forward to this. And just before I hand over to our speakers, I would like to thank our sponsors tonight, our gold sponsor, Hempel, who is a supplier of intermittent fireproof and durability paint for steelwork. Um, and also our silver sponsor, AGSI, Arabian Gulf Steel Industries, who's a leading steel manufacturer in the UAE, recognized for their commitment to sustainability and carbon neutrality in steel production. I'd like to also remind everyone about Elevate, which is our iStruct mentoring program, which focuses on career development and personal development. We'll try to put a page at the end. Elevate is aimed at members at every level. So those those of you on the call who are students all the way to fellow can make use of this excellent mentoring program that's offered by iStruct. Finally, a quick note on the content of what will be presented tonight. Our regional group assumes that all the approvals and permissions in relation to the contents of the presentation have been obtained by the presenters and no further checks have been done from our end as a regional group in this regards. Okay, I'm done with my notes. Thank you for your patience. I will now hand over to you, Azam, to kick off the presentation. Thank you.
Thank you, Iman. Hello, everyone. How are you doing? So tonight we're going to talk, as Iman mentioned, we're going to talk first about the voided slabs and the voided filling. After a little bit talking about CME structural solutions, and then Engineer Ahmed will start talking about the hybrid solutions, involving the voided technologies and other structural elements. And then Engineer Rasha will give us some case studies. So first, talking about CME. CME established in Dubai in 2014, and I'm sure many of you know us very well. We have since then tried to provide the market, the construction market, not only in UAE but also in the region with structural solutions that would save money and time and make construction easier, smoother, and faster on constructing companies and save money for all involved parties. In the Middle East, we started as in this picture on the left side. We started with the first slab in the Middle East. We started actually in Ramallah in Palestine, and as in this picture back in early 2014, before moving to Dubai and expanding to the region. Okay, main activities of CME would involve systems development. We have our own 3 systems for now, and we are getting accreditations for them from international and local authorities in order to be able to work with them. We also are a group of engineers. We're an engineering company, although we manufacture most of our products locally here in Dubai. We are an engineering company, and this is what really makes our services different. We provide value engineering studies in addition to regular structural design of slabs. We provide value engineering focused optimization and cover that with insurance coverage like professional indemnity insurance policies and other policies. Okay, as I mentioned, the main services would include either supply of materials and okay, I have mentioned that, no problem. Let's stick with this slide. So these are the main products or systems that we are doing now. So EVOS, the voided slabs, and the voided slab technology is about maybe by now about 30 years old or a little bit even more, and they started in North Europe about 30 years ago with a system or a company called Bubble Deck, then moved to another company called Kobiax. EVOS is our own system approved by International Code Council, ICC, and many local authorities in the region, including local authorities in UAE like Dubai Municipality. EVOS is about like the void formers in general, is about creating voids inside the slabs where concrete doesn't work or concrete doesn't help much handling the loads. The E-tension is the post-tensioning, regular post-tensioning system, as you all know. And E-fill is the voided filling system, and it is about replacing typical or traditional filling materials, volume or solid materials such as lightweight concrete, replacing that with voided filling. As we will explain a little bit more in the next slide, please, Rasha. So this is the concept of creating voids inside the slabs. Like as I said, as you all know, between tension and compression, concrete doesn't help much. Under the neutral axis line, it doesn't help much to handle the load. So it's a very old concept taught in universities about if it was possible to save this concrete while still keeping on the thickness of the slab. And yeah. So Engineer Ahmed will talk a little bit more about this, but as you can see, void creators or void makers, void formers are distributed in the slab, avoiding shear areas around columns and edges and openings or stuff like that. And this section, as you can see at the bottom, we have normal steel as any solid slab, and we have chairs as any solid flat slab. The only difference is that in some cases in the slab, we have void creators. And these voided slab thicknesses can vary between let's say 180 mm to 725 mm. And a covered area could be between 30 to 80% of the total slab area. Okay. So it's about like traditional. If we say a traditional solution, for example, is a solid slab with the drop beams or panels, like with EVOS, with the voided slab. In most of cases, slabs have, in most of cases, not less than 90% of cases, slabs would have flat soffits. Almost the same thing with the post tensioning. With hybrid voided post tensioning slab, the same thing. And as I explained, I'm sorry, with the volume or solid filling, like we replace the volume and solid filling with a voided filling, and the between the columns, the plastic columns here or pipes, there is a void, and then these plastic pipes we fill with concrete, so they and steel, so they work as reinforced concrete, let's say, columns, and on the top we put again concrete and steel mesh, so it works as the reinforced concrete slab. So in general, voided filling structure is like we could easily say mini reinforced concrete structure instead of this volume or solid filling, and it is much lighter in terms of weight and much more economical than any other solid or volume filling system, and faster, of course. So in some cases, we use also hybrid here. Again, Engineer Ahmed will talk about this next. Okay. If we go back to EVOS, to the voided slabs, and a small comparison with the many people mix between voided slabs and between ribbed slabs. Between ribbed slabs. In ribbed slabs, we use voided, like we use lightweight bricks or lightweight blocks, or even waffle or polystyrene or any material, in order for the same purpose, which is reaching the area where concrete doesn't work, and replace that concrete with the waffle or with the lightweight block, and this kind of like make slab lighter and cheaper. But unfortunately, with this like with the ribs, when we do that, we sacrifice the bottom cover, like we sacrifice the continuity of the bottom steel and the continuity of the bottom concrete, and thus we create T-section. And with T-section slabs, the stiffness of slab becomes very low comparing to solid slab. Like in this particular example, it's about 53% only of the stiffness of the solid slab. While with EVOS or with voided slabs in general, we do not sacrifice the continuity of the bottom concrete and the continuity of the bottom steel reinforcement, and thus the stiffness of the slab remains almost the same as the stiffness of the solid slab. It makes 93% of the stiffness of the solid slab, while we're dramatically reducing the concrete quantity, and also reducing the slab thickness. So if the solid slab, original solid slab, let's say 300 mm thickness, then with ribbed slab, it will become 370 or 380 or 360. like we are increasing the slab thickness in order to compensate the weakness that we created. And we need, of course, to use lots of steel quantities in the ribs, while in the voided slabs, similar to post-tension slabs, slab thickness goes down to 250 or 240, 260, something like that. And as I said, it does eye section. Okay, and the steel reinforcement also goes down. Okay, so if I talk a little about the EFIL or the voided filling system, as we explained, there are plastic columns that we fill later with concrete and steel, and the covers that again we load, we put steel reinforcement mesh on top of them, and we concrete, and thus we are creating many reinforced concrete structures. So instead of solid filling, and between, as you can see in the middle picture, between the columns or the pipes, there is about almost 60 centimeters space, free space, where services can be run easily, and the future maintenance can also be done easily. And the instead of huge weight of filling materials, this is very lightweight, very and very economic. Okay, this is as you can see, this is the section of the EFIL, structural section of the EFIL. A green color show plastic elements, which are I would say dead shutter, like they stay there forever, and they lose their value immediately after concreting. Okay, the red one or brown one shows the steel reinforcement, and how the reinforcement or the inverted U-bars go inside the pipe, and they are hanged on the horizontal steel mesh. And of course, as you can see, it is all concreted. Now, the height of this section or this system could be between the height could be between let's say, with the same system, between 15 to 300 centimeters, like between 0.15 to 3 meters. And of course, it's very important to mention that this has to be designed depending on the applied loads and depending on the nature of the applied load, whether it is static or dynamic loads, or are we having cars or trucks or fire engines going on top of this, or it's just something used in the landscape or anywhere else. Okay, as for approvals and accreditations, as I mentioned, for example, for the EVOS, we have the ICC, and we have some ACI committee members. We have Dubai municipality, other municipalities or ministries or organizations in the region in different countries. With regards to software used in the design, for EVOS we use SAFE and the ETAP for and for post-tension we use VAMP. So we use the same software, guys, that you all use everywhere in your daily work. Okay, with our systems, we usually do value engineering, as I mentioned before, for the slabs, and this affects not only slabs. Like when you make slabs thinner, lighter, and flatter, then you have lighter loads going on the vertical element and fewer reactions on the foundation, all resulting in saving in the steel and concrete labor, shuttering in time and everything. And of course, if you translate this to environment, like imagine, for example, with every cubic meter of concrete that we save, we prevent 210 kgs of CO2 from going up into the air. Another issue regarding environment is every truck that we send to the job site, every truck of materials of EVOS or EFIL that we send to the job site replaces the need to deliver in average 30 concrete trucks. Every truck, delivery of 30 concrete trucks. Imagine this effect on the transportation or traffic in especially in places like downtown or places where traffic is a big issue. In not mentioning, of course, that these EVOS and EFIL, we produce them here locally in Dubai, and we produce them from recycled plastic. I mean, from garbage. We take them from garbage. So they are recycled plastic, and this helps a lot in cleaning the city from recycled material, from plastic materials or plastic waste. Okay, we, as I mentioned before, we provide insurance policies to cover the design and also to cover the materials, the systems. Another one. Manufacturing, we do manufacturing locally here in Dubai, as I mentioned before, except for the post-tension components we import, of course, as everyone else does. And the supply of materials to job sites, they come like in this, unassembled. These are some, we do also training at the supervision at the job site for the contractor work, for the contractor team. Okay, so now I give you Engineer Ahmed, Haj Ahmed. I give you the floor. Please go ahead with the hybrid system, talking about hybrid systems.
Yeah, good evening. We shall speak about the hybrid systems in our from our main systems. As you are already now know, our main systems in CME structural solutions are three main systems, which are the EVOS voided slab, the EFIL voided filling, and the E-tension, which is a post-tension. From these three elements, three systems, we can combine any two or more or the three of it to get other systems like EFIL EVOS system, EFIL PT system, EVOS PT system, EFIL EVOS PT, or CME's hybrid structural solutions, which are based from on the semi-precast elements. Now, the EVOS, as an engineering concept, as Mr. Azam have already told, that we are targeting the area of the concrete or the volume of the concrete inside the slab, which is not acting in the resistance of the section. So whatever concrete is below the neutral axis, this concrete is not working because it is in tension. So our section, which is working in the concrete section, which is the compression part of the void of the slab of the section. So we can remove the concrete from the middle, keeping the bottom layer, which will help us in getting the I section instead of the T section, and also in placing the bottom mesh, which will help a lot also in reducing the reinforcement ratio. The voided slabs will have about 30 to 80% of the area filled with the voids, keeping in mind that the area around the supports are kept all solid because these areas are suffering punching shear there, punching shear status high. So we'll keep it as a full concrete thickness. The interface between the solid part and the voided area around the column is defined by the one-way shear also. So wherever we calculate the one-way shear at the perimeter of the column in order to define wherever we can stop putting voids inside the slab. Also around the edges, at the edges of the slab, we don't put also in around the openings, we keep it also free of voids. At the end, we will get a section for the EVOS system, which will have a bottom mesh, which is the red color in the bottom, and a top mesh, which is the red mesh in the top. The voids in between. The voids are kept in something that we call it a steel cage, which is the yellow. Now, this steel cage helps a lot in addition to the keeping the voids fixed at the proper location, helps also as a shear connectors if we have some cold joint during the construction process. Design of the EVOS slabs can be done by any standard or code like ACI or Eurocode. Of course, we have got also the ICC and ACI accreditation, and which concludes that EVOS voided concrete slab system can be used to design and construct concrete slabs in accordance with the ACI 318 requirements. All slab design requirements of ACI 318 and complied with it. EVOS slabs are designed as solid slabs according to ACI 318 or any other code using SAFE, ETABS, or any other finite element software after considering these three factors. Now, the voids in the slab affect the slab in three main points, which is it's reducing the volume of the concrete, means it is reducing the self-weight of the slab, so we have a reduction in the dead load. It reduces the shear resistance. For that, as we told, we keep around the columns full concrete. There will be a factor used in the design, which is, let's say, conservatively 0.5. And it also affects the stiffness of the section. Now, the stiffness in the section, as it is an I section, and the void formers are ellipsoidal void formers, it gives a good stiffness which is close to the full section, like 0.93, 0.91D in this average. So the reduction in the stiffness is not that much. In our designs, we reflect these three elements, these three factors in the software that we are using. Of course, the structural forms of EVOS slabs can be flat slab, flat plate, with drop panels or drop beams or inverted beams, with with the precast elements or with post-tension system. We can use a post-tension, as we told, as a hybrid system, which is a post-tension voided slab, EVOS slab. As a combination of EFIL filling, voided filling, and EVOS slab, we can get a hybrid system in which we can replace the soil filling. If we have soil filling on top of a slab, we can replace the soil filling or part of the soil filling by EFIL system, which will reduce the soil imposed soil load on the slab. And also we can reduce the self-weight of the slab by using the EVOS slab system. This combination helps a lot in ground floor slabs or podium slabs that have this landscaping, in which the quantity of the reinforcement is dramatically reduced, and also number of drop panels is also minimized a lot. For the hybrid voided PT slabs, we have the option that normally we use in the post-tension, which is we can use the post-tension as distributed in both directions, or banded in both directions, or banded distributed in each direction, or we can use a voided EVOS voided slab with PT beams. Now, why we are using hybrid system, or why we are developing the hybrid system? Because the hybrid system, which is the voided post-tension slabs, combines the benefits of both systems, which is the voided system, the voided EVOS voided slab system, and the post-tension system. The EVOS slabs reduces the self-weight. The post-tension slabs also reduces the thickness and also helps a lot in controlling the deflection and the crack widths in the slab. Combining these two systems together, we can reach ultra-long spans, providing greater flexibility in the layout design. In architectural layout, it's flexibility. The reduced quantity of concrete is also a very good reduction. We are getting thinner, lightweight slabs to optimize the structure and the foundation. Superior crack and deflection control by using the post-tension slab, post-tension system. Enhanced sustainability. Significant reduction in total steel reinforcement. Superior optimization in vertical elements and foundations and construction material. And of course, at the cost saving, we are saving in the slabs, maybe we are saving in the verticals for sure. Lighter slab, thinner slab, which will reduce the reactions on the foundation and on the vertical elements, which will reduce the sections, saving concrete and reinforcement. As an approximate comparison between an RC slab of 300 millimeter thick with our E-tension system or EVOS system or the voided PT, which is a hybrid. For the 300 RC slab, it's around 260 millimeter for the post-tension, E-tension, 260 millimeter also for the EVOS voided slab, and around 240 millimeter for the voided PT slab, which is the hybrid system. The reduction in the concrete volume will be around 15% in the post-tension, E-tension, 30% in the EVOS, and around 35% in the EVOS PT. Steel reinforcement also, we have a reduction in E-tension 30%. In EVOS, we have around 15%, while in voided PT we'll get around 35%. For the drop panels, around 70% of the E-tension of the drop panels compared to RC are removed by the post-tension E-tension system, and around 90% in the EVOS voided slab system, and around 95% by the voided PT slab system. As we told earlier, that also we can use our systems based on the precast, semi-precast elements, in which we can put the void formers on top of these precast elements, which will help a lot in the shuttering system. It will be acting as a dead shutter also. So we can combine these two to get a great system that will help in big areas which need to reduce the quantity of shuttering, wood shutter or aluminum shutter or any other shuttering system. As an example, we are putting here a plan that we have for the voided slab. The green colors are the void formers. The white colors are the no voids around it. It's either solid or a solid area. And if we have a drop panel, it's marked with a square or rectangle around the support. Now, in between the columns or supports, we always keep a solid part which connects these columns and supports together, without the presence of any void in this let's say collector or line of connection between the supports. Going through the design, we'll have some parts which are voided areas and some parts which have solid areas. Now, the spacing between the void formers, center to center, is 350 millimeter. We keep around 600 to 800 millimeter around the slab edge. Around the column, we keep minimum 1 meter, or as per the design, based on the one-way shear. And this will be reflected in our modeling. For the slabs, if it is EVOS alone, we use the SAFE. If it is EVOS PT or PT, we use the RAM concept. These areas will be defined in this modeling process. So if we are using a SAFE model, we will define the areas where we have the voided area, which is the area that we have the void formers. In this area, we will define the 3 factors that we spoke about, which is the reduction in weight, the reduction in shear, and the reduction in the stiffness. So in the bending M11, M22, M33, M12, we will put the factors which are the stiffness reduction factors. And in the V12, V23, we will put the reduction factor of the shear factor. While we will go to a case, which is the dead load case, and we'll define a reduction in weight, in load, which is a negative load in this voided area only. The other areas which are not voided will be kept as normal, which is the factors are kept all as 1, and there is no reduction in the slab weight. Now, these factors, which are we will define in the M11 or the membrane or the shear, or the reduction in weight are based on our schedule in which we have these factors for each thickness and for each void former, because it depends on the void former height and the slab thickness. Of course, we will also work on ETABS in order to get the lateral stability and thermal, whatever lateral loads. So modeling the EVO slabs in ETABS will be the same also. We will define the stiffness reduction factors in the bending modifiers, and the shear modifiers, we will put also these reduction factors. We can put at the 0.5 as a conservative value. Of course, in the bending, depending upon the type of the slab, if it is RC slab, normally we use 0.25 as a factor in the solid RC slab. So in the membrane and the bending, we will multiply the stiffness factor by the 0.25 and define it in the ETABS model. Of course, also load reduction will be defined, but in ETABS, we normally use as a full reduction in weight, because we cannot go through defining the area, voided area and solid area separately. For the membrane modifiers, which is F11, F22, F12, we also define it based on the factors originally used by using a ratio, which is the EVOS slab weight to the solid slab weight with the same thickness. So what we are doing here is we are getting the percentage of the concrete which is casted in this section. Of course, this will help in the membrane. The other factor, the other areas, which is a solid area, we're not defining it or keeping it as the ETABS only. In RAM concept also, we will define the EVOS area. The yellow parameters are the parameter of the voided areas. And we can introduce in the definition of the slab the stiffness factors and the shear factor. Of course, EVOS slabs are not treated other than the RC slab in the diaphragm issue. These void formers which are inside will reduce a little bit the collaboration of the slab in the horizontal transfer of the load, but we are keeping the connection between the columns also, which will help in this issue, and keeping these collectors or solid will translate the horizontal load by the diaphragm action. In the diaphragm, of course, we will use the ETABS. We can take section cuts at the required sections, and we will get the moment and shear and design the sections based on these straining actions. Of course, when we are designing an EVOS section by manual calculations, we always ensure that the neutral axis is lying within the top flange or the topping slab. So for EVOS PT, as we told, it combines the benefits of both. So we'll have voided area with PT tendons around it. This is also a voided a slab with PT beams. So we'll have post tension and voided areas. also as photos for them. Thank you very much. Rasha.
Yes, good evening. Now I will discuss two projects where we used our system to achieve the client's different target by using EVOS and E-tension and hybrid EVOS post-tension. Also, we use EFL system. So the first project, it is a residential and commercial project. The total area of the project is around 147,000 square meter. This project consists of 8 floors, which is a common area. Above these floors, we have 2 towers. The first one, Tower 1, consists of 22 floors, and the other tower consists of 17 floors. The original slab system is a solid slab with some drop panels and some drop beams. And this solid slabs used in the basement slabs, and in the podium and upper floors of the 2 towers are post-tension slabs with different slab thicknesses, also with some drop panels and drop beams. So the target of this client was to optimize the structure in order to reduce the construction activities and to get saving in the cost of the project. So we, in our value engineering, we managed to reduce the drop panels. Actually, in the basement or in the substructure, we removed totally the drop beams and the drop panels. And in the upper floors, we reduce the number of the used drop beams. Accordingly, this eliminating the drop panels, which leads to increase or decrease the construction time. So we save the in the shuttering and in the steel work of these drop panels, we reduce because we eliminate some of these drop panels and the drop beams. Here we will talk about the value engineering results for the common area, which is the basement and the podiums. Here we studied a voided slab, which is EVOS, and compared with the original design. In the basement slab, which basement 1, basement 2, and the ground, the original design solid slabs with 25 and 30 centimeters thicknesses. We managed to reduce the slab thickness by using EVOS voided slab. We reduced the slab to 23 instead of 25, and 25 instead of 30 centimeters. And we, as in the solid, in the original design, we don't have drop beams. While in the drop panels, we remove the drop panels used. We don't use any drop panels in this option. Accordingly, we reduce the slab thickness by 32.6% comparing with the original solid slab. So here we reduce the slab thickness and we remove all the drop panels. Accordingly, the steel reinforcement will be reduced. So it is 39.1% reduction in the steel reinforcement. This is the total steel. I mean that the gravity, thermal, and lateral steel. This is in the substructures, and in the superstructure, which is the podium. In the original design, the original slab thickness is 22 centimeters post-tension slab. We redesigned these slabs and converted to EVOS voided slab with a 24 centimeter instead of 22. Here we increase the slab thickness by 2 centimeters, but we remove the total drop beams and total drop panels. In the original design, they have 12 drop beams. We remove all the drop beams, and they have 50 drop panels. We remove all the 50 drop panels. Accordingly, we increase only the slab thickness 2 centimeters, while we remove the total drop elements.
Slab width.
Slab width, yes. So the slab weight here is reduced to 21.2%. As we know that the post-tension, the normal steel in the post-tension is less than the RC slab. But in our case here, our normal steel is more than the post-tension. The normal steel in our case is more than the normal steel in the post-tension by 13.5%, while we remove 100% the PT. Our slab is RC static slab, comparing with the BT slab. Here the results for the Tower 1. In Tower 1, we study typical slab, and in 3 options. We study option number 1, EVOS avoided slab, comparing with BT slab, and the option 2 is E-tension BT slab versus original BT slab, and the option number 3 is hybrid avoided BT slab versus BT slab. So here we managed to, in option number 1, we reduce slab thickness around from 2 to 5 centimeters comparing with the original BT. And also we eliminate some of the drop beams. We use 3 instead of 11 as in the original design. And we use the same drop panels as in the original design. Accordingly, we reduce the slab weight by 19.9% comparing with the original BT. Comparing to the normal steel, our steel is 17% more than the normal steel in the BT slab, while we remove 100% the BT steel. And option number 2, which is E-tension post-tension, comparing with the original post-tension, we reduce the slab thickness by 22 centimeters instead of 25, and some area of the slab, of the studded slab, we keep the same thickness, 25, and in other area we reduce 3 centimeters, 25 instead of 28 centimeters. Also, we reduce the number of drop beams. We used 3 instead of 11, and we use 14 drop panels instead of 13. Accordingly, we reduce the slab self-weight by 8.9%. And the steel, the normal steel, we reduced by 17.2% comparing with the original BT. And the third option, which is hybrid voided BT, we reduce the slab thickness 20 centimeters instead of 25. So we reduce the slab thickness in some areas. And also we eliminate some of the drop beams. Accordingly, we reduce the slab self-weight by 20.5%, and 17% we reduce the normal steel comparing with the original BT.
And Rasha, if I would add to what you have said, like just sharing that with the hybrid slab, like with PT, we reduce lots of steel reinforcement. With EVOS or with voided slabs, we reduce lots of concrete.
Yes.
With hybrid slabs, we reduce both the maximum. Like both of them are, the reduction in both of them is maximized. Now, it is worth saying that hybrid slabs are not suitable everywhere. Like in about maybe less than 20% of cases, hybrid slabs are powerful, but in remaining slabs, it would be either EVOS alone or post-tension alone. Okay, can you rush a little, Rasha, because I think we're in time here. Time. Okay, please go ahead.
So in Tower 2, the same way that we studied the 3 options, and we reduced the weight and in some case the steel reinforcement. And this engineering results we reflect as a commercial result, and we compare the commercially what we can achieve to this project as a total. For the total project, I mean the podium, basement, and Tower 1, Tower 2, the total saving comparing original slabs designed with our slabs. This project saves around 11 million dirham as a total only from the slabs. If we compare slab to slab only, without considering the reduction in the weight in the vertical element or in the foundation. So we achieve what our client needed from us. In the second case study, this project, the target of the client in this project is different. They have already casted the piles and the raft foundation, and based on design the 22 floors. And the client or the owner of the project managed to increase the floors, additional 4 floors with the same piles and same foundation. So in order to do this, they approach us in order to help them to reduce the slab self-weight and manage to increase these four floors. So what we decide to do that we use our slab systems, different slab system, and at the end we found that the EVOS voided slab in this case is the better solution to reduce the own weight of the slab, and then the total weight of the slabs will be reduced. So we convert all the solid slabs and the post-tension slabs to EVOS voided slabs. Also, they have in this project cantilever. This cantilever area, they have a swimming pool. Around this swimming pool, they use traditional filling material. So we managed to remove or replace this traditional filling material with EFL system. So we reduce the superimposed load on the suspended slab. So this is the second way we use, or the second solution. And also they have some green area, they use 1.7 meter as a soil. So we replace some of the height around, we replace 9 centimeter of the soil by EFL system, and we kept for them 7 centimeter for the planting. So by using these 3 solutions or 3 ideas, we managed to increase the slab self-weight and reflect this reduction in the slab weight to the vertical element and foundation. And we guarantee to our client that they can add 4 floors to the existing piles and to the existing foundation without any strengthening or any need for strengthening.
In addition to money saving.
Yes, absolutely. They have around 3 million saving from slabs on the slab to slab.
By the way, your camera is off, Rasha.
Okay.
Okay.
Yes. Thank you.
You finished?
Yes, I finished.
Okay. Good. Guys, I think it's Iman. You have the floor now. Yeah.
Thank you very much for this very insightful presentation. The case studies, I think, were very enlightening to show the comparison. Thank you for that. So we've got a few questions coming in. I'll start with the Zoom chat. A question from Hardeep Sharma. Does making voids make the slab prone to punching? If yes, do we provide solid section there, or is there any other criteria to cater for voids? So by voids, I believe it's referring to penetrations. So
as we told in the presentation, around the columns, we don't put any void formers in which we keep the full thickness of the concrete acting to resist the punching shear.
Okay, so if there is a concentrated load or anything like this, you do the same?
Yes.
Okay.
If there's a planted column, let's say, or any concentrated load, below this area, we don't put any void form.
Great, thank you. Second question from R. Vurugonda. Can the voided slab be used as a cantilever like balconies or other location?
Yes, we can.
And is there a limitation for how far we can go, or depends on the depth and load, etc.?
Yes, it depends on the slab layout and the applied load.
Right. So yes is the answer. Thank you for your question. Another question also from R. Vurugonda. How MEP services slab cutout and opening are considered in voided slab? I think we've seen some examples in your plans where you have introduced penetration. Maybe we can tweak the question as in, is it possible to do penetrations later in the life of the voided slab?
Yes, we can. I'm sorry, Haj.
No, please.
Yes, we can. I will take the answer here. So yes, with the voided slabs are dealt with after concreting, exactly as you deal with any solid slab. So because once concrete is cured, the void creators inside the slab are nil, like they mean nothing. So let's say half an hour after concreting, you can consider the slab as solid slab with some voids or with some cavities inside. So you deal with it exactly as you deal with any solid slab, unless, of course, it is hybrid. If it is hybrid with the precast elements or with the post tensioning or with any other thing, then you need to consider the restrictions coming from the usage of the other system, as for example with post tension.
Yeah.
But as voided slab, it's solid slab, and you can do coring, you can do opening, you can. I mean, after construction, but even during construction, it's very flexible to if you have any last moment changes and you need to cancel some void creators or replace them with the electrical or mechanical elements.
Right. Thank you very much. And this covers the third question from Shiranjaya. Thank you for your questions. A question from M. Al-Nagar. If it's used in a seismic zone, what is the effect on the diaphragm design?
So in diaphragm design, as we spoke about it, in diaphragm design, we keep solid parts in between the supports, and the diaphragm actually acts the same with a minor reduction in the stiffness. The collectors and this diaphragm is designed based on the E-tabs. Straining actions, we design it the same as we design the solid concrete RC section. But of course, we ensure that if it is in the voided area, we ensure that the neutral axis lies within the topping concrete.
Right. Thank you for the answer, Mr. Ahmad. A question from Mustafa Batiha. Have you compared a traditional post-tension hollow core slab with a plastic void post-tension slab? In both cases, almost the entire section is in compression with a limited zone in tension. Therefore, the plastic voids will not make a significant difference. Any insights on this? So instead of the plastic voids, we have an actual void and the PHS slab. How do they compare?
For the comparison between the hollow core and the voided slab, it's a lot of differences there. In terms of the construction, it's that the hollow core is a precast element which have pre-stress and have a lot of restrictions for MEP openings, cores, etc. While the EVOS voided slab is a cast in situ, which permits anything without dealt as an RC, doesn't have any let's say restrictions for coring or MEP openings before or after casting. On the other hand, also the hollow core is a one-way slab which have a topping. The differential movement, if it's a car park or something, you will feel the vibration a lot. While in the EVOS cast in situ slab, this doesn't have, it's a biaxial slab system. and its cast in situ doesn't have any precast part unless we use the semi-precast. Even if we use the semi-precast, the minor part of the precast is a small. The precast element, I mean, is the minor part, which is a small thickness, while the major part of the EVO slab will be the cast in situ concrete.
Right. Thank you very much, Ahmad. This is very clear. I guess the major difference is it two-way versus one-way. That's a big one, as you have rightly mentioned. Thank you, Mustafa, for your question. There are a few questions from YouTube, from Mustafa Mabrouk. How to calculate the unbalanced moment induced when voided slabs are used as part of the lateral load resisting system?
The same as we calculated in normal post-tensioning, with a reduction in the self-weight. Now the stiffness is a little bit different, a little bit reduced, but in this it will be taken into consideration when calculating the section properties, which we will use in calculating the unbalance.
Okay, thank you. A continuation also from YouTube. For the voided PT slab systems, how the collectors and cord will be designed, located, etc. for the slab diaphragm?
For the slab, for the hybrid, normally the spacing between the void formers is bigger because we need to put post-tension tendons in between the voids if it is distributed. So the stiffness will be higher. The location of the collectors and are defined the same as we use in RC slab. Normally, as we spoke in the presentation now, that in between the supports, we always keep solid part, which will give a good performance for the collectors in that area. The design, again, the design of the section will be based on the, if it is in the voided area, will be based on a voided area, voided section. And of course, will come again that the neutral axis will be checked to be in the topping flange.
Yeah. Thank you for the answer. There are a couple of questions still coming in. We'll try to move quickly through them. The next one is from Abdul Fattah. What's the fire performance in the voided slab, especially as plastic is known to have a low melting point? After a fire incident, how can the continued performance of the voided slab be determined?
Now, for the fire resistance depends on the slab thickness and the cover of the concrete cover to the reinforcement. As the section of the EVOS show that the void former is fully encased inside the concrete with a minimum topping or bottom concrete thickness of about 50 millimeters. This is the minimum. So we consider the fire rating based on the cover of the concrete, and we follow the codes for the concrete cover around under the bars or on top of the bars. Now for the void former, in case of fire happened, void former is a nil. It's not a structural element, and it doesn't affect the slab. It doesn't chemically react with the concrete. It only, if something fire happens, it only melts, which will not affect the slab integrity. Of course, the fire will affect the slab integrity, but not what I mean is not the void former itself, which is melting or suffered fire around it.
Thank
What
you
is the
very much.
cover that we need to take care of?
Yes, yes.
The cover
yes.
under the reinforcement is what we need to take care of. And as per, like in Dubai, for example, as you all know, it is usually 25 mm the use, and that secures more than 2 hours fire rating. And if someone needs more, of course, this has to be increased as much as it is allowed by the code, of course.
Yes, thank you very much. We have a question from YouTube with a few folds. I'll take it one by one from Shapoor Merkar. Nice presentation. What is the cost of the redesign is the first question. I think, so considering a traditional form is there and we're switching to the voided slab.
So the answer is that share with us. We will look at it and advise.
Sure.
You
How
need
many
to share
projects?
that.
Yeah. How many projects has your system been used already? Any indication?
I think we exceeded 500 now, and not only in UAE, but in the UAE and neighboring countries.
Thank you. Is there any extra time required in placing the void former? And maybe this question also comes with specialist skills. How do you train the contractors on site? How do you need your team to be present? How the practice happens?
So that's a practical and perfect question, actually. Voided slabs are in about 30% faster in construction or in a concreting cycle than post-tensioning slabs, unless we are talking hybrid. If we are talking hybrid, then we have the same speed as post-tensioning slabs. So, for example, if for a certain slab with a certain area, we need to finish or to like a concreting cycle between two slabs is, let's say, 6 days. With the EVOS or with voided slabs, it could be reduced to down to 4 days. And the reason is the simplicity, and that like you attend, it's very easy. It's very easy, very simple. Like you put down bottom steel reinforcement, then you put the void creators, those green elements in the picture here. They don't have to be green, by the way. And then the steel cages that we use serve as chairs for the top steel. So after placing the void creator, we can immediately place the top steel on top of these steel cages and concreting. So it's very easy, and also last moment changes are very easy to handle. Another issue is like continuity, as we need with precast or with post tensioning. Continuity is not needed during the construction of a voided slab. Like you can start with a part of the slab, even if the second or the other part or the other end of the slab still doesn't have shuttering. You can still do the work here. So flexibility guarantees the speed and the simplicity.
Sure. And the labor, skilled labor on site, do you rely on usual contractor teams that you train, or how do you proceed?
Yeah, usually we provide training and supervision, and our engineers are always available at the job site at the time of placing the void creators. But again, it's very simple, and we require from the contractor very, very, let's say, basic labor. It's very important that they have like, let's say, a team leader or supervisor or an engineer or whoever, together with our engineer. That's it.
Thank you very much. I'll try to take 3 more quick questions. There are more questions coming in, but hopefully they can reach out to you directly, given the limited time. Can we use this system as a raft foundation?
Yes, we can.
Okay, Rasha, go ahead.
Oh, sorry. Yes, we can use it.
Okay.
We like theoretically we can, but it is not allowed by authorities. Like DM does not allow for that. In other countries, like in Iraq, for example, we've used that. But in UAE, like I know that definitely DM does not approve that.
Yeah, okay. So that brings me then to the next question, that in terms of authority approval for the slab itself, you have no issues with the authority for this system since you've already covered forward. Very good. A great question from Sid Dars. How can one become part of CME and learn and contribute to such an amazing work? Professional engineer from India is asking the question.
Well, please contact us. we welcome all suggestions and contacts and just contact us. Get in touch with us. I'm not sure, Iman, are you sharing our contacts anywhere or?
I think there was on
email?
on your last slide, there was an email for CME solution. Maybe if we go to the last slide, everyone can take note of the contact and they can get in touch with you. If you scroll to the last slide, Rasha, please. Excellent. So yeah, very good. So apologies for the rest of the questions that we cannot take today, but obviously you can reach out directly to the email address on the bottom left-hand side and ask your question directly.
That's a website. Is there an email here, Rasha?
Yes, we have the email here. Yes.
Okay. Because my screen is not showing. Okay.
Okay. All right. There's also a small quiz that we're going to post on the LinkedIn page to test your attention and your knowledge learning. It will come in the next few days on our LinkedIn page. So please visit the page and try to attempt and answer the questions. They will be related to the presentation and the information that was presented to you today. And you can always come back to the YouTube and review the presentation materials. Other than that, I would like to thank you, CME team. It has been an excellent presentation indeed. A lot of new information acquired today. Thank you. And I would like to thank all the audience and invite you to look out for our next event, which will take place on 16 October. And that will be a joint event between ICE, IStruct, and CARES. It will focus on sustainable steel. And hopefully we will have two guests of honor joining us. It will be a hybrid event. So look out for comms coming soon on our pages. Thanks again and good evening, everyone.
It's been a pleasure. Thank you.
Thank you.
Thank you.